This is a video to show you how to derive the formula for the range of a projectile. And this very handy formula only applies when the projectile starts on the ground and ends up on the ground. I call it a ground-to-ground projectile. So it does not work if it's off a cliff or up onto a mountain or something. So it has to start at the same elevation as it lands. So we have the initial velocity vi, which is a vector, at an angle theta with the horizontal. So we'll write the equations for the x and y directions, as we usually do. And remember, we always resolve the velocity vector into components. So we have the x component and we have the y component, and we'll analyze the two motions separately. So in the x direction, the initial velocity, vix, is vi cos theta. And in the y direction, viy is vi sine theta. Now, sometimes the tricky thing about these problems is you're not given the initial velocity. And if you're not given the initial velocity, you feel like you're dead in the water right off the bat. Okay, so we need to get an equation that has the variables that you're given in it. So what I want to do is calculate the time in the air. Okay, so that's the thing, time in the air. And that is determined by the y velocity totally. So the amount of time it rises and falls due to gravity determines time in air. Okay, so we will analyze the position on the ground here. So this is a point of interest as far as determining time is concerned. Now, what we know about the motion in the y direction is acceleration is always negative 9.8. And we also know that the final velocity at the ground, so VFY, is the negative of the initial velocity. So if it's shot vertically up at 10 meters per second, it's going to rise, go to 0, turn around, come back down. It's going to land going vertically negative 10 meters per second. Okay, so if that's the case, I'm going to use this equation that VFY is VIY plus AT. And so I get that the time is VFY minus VIY divided by A. That is the time in the air. Okay, so I'm going to put these values in. VFY would be negative VIY minus VIY divided by A. And so we see that the time in the air is negative 2 times VIY over the acceleration. And remember, VIY is VI sine theta. And the acceleration is negative 9.8. So you can see that this is a positive quantity, as it should be. So T is 2 VI sine theta over 9.8. Now, we can't calculate that if you're not given VI. And that's one of the problems you have on your Mastering Physics assignment. So now what we're going to do is this time is also what dictates how far it goes sideways, because it's the time in the air determines when it's going to hit the ground, and it's the horizontal velocity that determines the range. Okay, so I'm just going to write these equations again down here. So we have Vix, remember, is Vi cos theta. And then the only equation we have in the x direction, because acceleration here is 0, is that delta x is Vix times t, because the 1/2 at squared is 0 here. And so delta x is Vi cos theta times t. Now, this delta x, that's the range. That's called the range. So some books will literally call that r. And what that means is that's the distance it travels along the ground. So this is the range, r, which is equal to delta x. Okay, so I'm going to take the formula from the y, and I'm going to put it in to the x. Okay, and this will give me the range formula. So delta x is Vi cos theta. Now that time I'm going to put 2 Vi sine theta divided by 9.8. Okay, so we get VI squared times 2 sine theta cos theta divided by 9.8. That's delta x. That's the range. I can put R here as well if you like. Okay, now this is an identity, and you don't necessarily know what that identity is, but 2 sine theta cos theta, this actually equals sine 2 theta. And so the range formula, very handy formula, is VI squared times sine of 2 theta over 9.8. So that is the range formula for ground to ground only. So it has to, because remember, I assumed that the vertical velocity was the same, but an opposite sign on the way down. That only happens for ground to ground. Okay, so it means that, for example, in your Mastering Physics assignment, you were given that R is, somebody told me it was 11 meters, and theta was, I think, 22 degrees. And the question is, find VI. And normally that would be quite tricky, but with this handy formula, you just pop it in. 11 meters equals VI squared times the sine of 2 times 22 is 44 degrees divided by 9.8. And then you can go ahead and solve for that VI. VI squared would be 11 times 9.8 divided by the sine of 44. And then that would be it. And then square root that to get VI. Okay, so that's good.